All right, Unit 7 for geometry, target 2. I can use the midpoint formula to find the endpoint. As a reminder, the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. There's a few different ways to accomplish target 2. I'm going to show you two mainly in this video with using a graph as well as using an algebraic formula. And then I might also show you a third way using transformations. And you need to be comfortable using at least one method. But if the method you're using is graphing, then you probably need a second one as well, because not all problems are going to be able to be graphed very easily. So let's get started. So this problem says the midpoint of RS is M at comma 1, 2. So let's start there. So 1, comma 2, we have a midpoint, M. One endpoint is R, which is at negative 6, 6. So R is at negative 6, 6. And I have another endpoint S, and I don't know where that's at. It's at X, comma Y somewhere. That's what I'm trying to find. And so the idea is I'm trying to figure out where I could draw this line and stop somewhere over here to get the other endpoint. That's what I want to try to figure out. So by looking at it on a graph, I can kind of calculate the distance using a slope distance, which is something that we've done in the past. We've counted slope using our horizontal and our vertical components. So to go from R to M, I'm going vertically down 4 and horizontally over how many? 6, 7? So I went down 4 and I went over 7. And so I could do that again using that exact same distance, that ratio, down 4 and over 7. And that would give me my other point, S. And so graphically, if I have a graph in front of me, I can plot the points and count the boxes and use that distance. It's similar to what we did with a 180-degree rotation in Unit 4, where we counted the distance and then continued to count that distance. It's also when we counted the distance from a point to a line with a reflection, we then kept going past the line and used that same distance. So that's strategy number 1, is to use a graph. Along with that strategy, maybe without even thinking about the graph, is to think about it as a transformation. If I went from point R and I went from point R to M, and then I went from M to S, because I want the distance to be the same from R to M as it is from M to S, however I translate R to M, I need to translate the same way from M to S. So if I write it as a translation vector, from R to M, I went 7 to the right and I went down 4, which means when I go from M to S, I'm going to go 7 to the right and down 4. Now I can come up with those numbers with the graph or without the graph. For example, if I have R, I'm at negative 6, so I just circled that, and I'm trying to go from negative 6 to 1. Well, how do I turn a negative 6 into a 1? Well, I add 7 to it. If I then thought about the Y values, I'm trying to go from a 6 to a 2. How do I turn a 6 into a 2? Well, I have to subtract 4. If I then take those numbers at M, which is 1, 2, and I apply those numbers, 1 plus 7 is going to give me my X coordinate, and 2 minus 4 is going to give me my Y coordinate. So at 8, negative 2 gives me the point S on the screen. So that's option number 2. I'm going to group those things together and make them smaller. So I really like that method as a kind of an informal way to do the problem. And I really like the graphing method because it happens so quickly. But the first thing that actually comes to my mind is to solve the problem using algebra. It is a technique I think that takes a little bit of time to practice and to fully understand, but it is something that will work regardless of how big the graph is, so that if it's beyond the number 10, you can make it work. Or if it has decimals or fractions, this will always work. And so I'm going to back up, erase some numbers here. and use the actual midpoint formula. I'm going to write down the midpoint formula below the graph so I have a reminder of it. So I'm adding the x's and dividing by 2, and adding the y's and dividing by 2. And I know this is going to be one of the longer videos because I'm showing you 3 ways to do the same thing, and the third way does take a little bit of time. So the idea is stick with what you've been doing. In other words, add the 2 x's and divide by 2. So -6 plus x divided by 2 should give you the x-coordinate of the midpoint. So since I don't know s, I don't know the other endpoint, I have an x there, so -6 plus x instead of -6 plus the number. So instead of just plugging in a number and simplifying it, I have to set it equal to the midpoint. The midpoint value for x is 1. I just circled it in the top. And so that gives me an equation to solve. For the y coordinate, I can do the same thing. For y, I have y plus y divided by 2. So 6 plus y divided by 2. That will give me the y coordinate of the midpoint. But I know the y coordinate of the midpoint. The y coordinate of the midpoint is 2. And so now I have 2 algebra equations that I can solve in order to find x and y, which would be the coordinates for s. To solve these equations, I'm going to start by multiplying both sides by 2. When I multiply an expression by 2 and divide the expression by 2, those operations are inverses, and so they cancel each other out. If you multiply and divide by 2, you're really multiplying by 1, which doesn't change anything. So I have -6 plus x. And on the right side of the equation, I have a 2. Then I'm going to add 6 to keep going, and I get x equals 8, which is what we know already. We know this point is 8, -2. But if we didn't have the graph, we would have just found the 8. I'm running out of space here and getting all jumbled, but I can keep going. If I have the y coordinate, same way to solve the problem. I'm going to multiply this side by 2 and this side by 2. Make that not look like an exponent. So now I have 6 plus y is equal to 4. And if I subtract 6, I get y equals -2. So 3 different ways to find midpoint. Feel free to watch the video again or rewind and watch parts. And then talk to your math teacher or myself if you have questions.